This is Mr. Anderson for Kellogg Community College, and we're going to be looking at sections 3.3 and 3.5 in Chapter 3, looking at applications of systems of equations. This is where we can solve two equations with two unknowns and three equations with three unknowns, and how the story problems set them up. We got three problems in section 3.3 that we will set up and see through completion, and our first one talks about jewelry design. Starbright Jewelry had 80 beads for $39, and some beads were 40 cents, some beads were 65. So how much of each bead was purchased? Now what I like to do in these equations with two variables and two unknowns is I like to first of all identify the x and the y. Now it says some beads were 40 cents. Let's call these the x variables. And some beads were 65 cents. Let's call that y. Because these were definitely two different types of beads, and we want to make sure what we define our variables by how many there are. Now the two rows I'm going to come up with, there's a total row which talks about the total number of beads I have, and then there's going to be a cost row which talks about the money. Now in the first sentence it says here is that the jewelry design have 80 beads for $39. So the total row is going to be my x beads, and my y beads is going to add up to a total of 80 beads. I'm either going to have 40, 40, 30, 50, or as wild as like maybe 5 and 5 and 75. But another row we need here is we need the money row, which is going to be 40 cents for every x bead and 65 cents for every y bead, making a total of $39 that we got from the first part of the sentence. So if it helps to circle all the numbers in the problem, this is what's going to go in the problem. Anything with money is going to go in the money line. Anything that's not a money item is going to go in the total line. And we don't have any qualifiers to tell us how many more x's than y's. So all we have to know is that x and y add up to 80. So from there, we're going to now solve using the elimination method. And what I'm going to do here is multiply the top line by a negative 40 cents. If I multiply the top line by a negative 40 cents, then every single x, y, and 80 gets multiplied by that 40 cents. So now I have negative 40 cents x plus a negative or minus 40 cents y. And $80 times, or 80 times the negative 40 cents is negative 32. Now below, the equations stayed exactly the same, so I just brought that over. 40x plus 65 cents y is equal to $39. If I add these up, these simplify to 0. This makes 25 cents y, and this is going to make a total of 7. Dividing both sides by a quarter, or 25 hundredths, y is going to be equal to 28. So this means out of the 80 beads, 28 of them were the y bead. To figure out my x quantity of beads, I would simply take my 28 and plug it into my top equation to figure out how many x's were left. And I would subtract both sides by 28. And x is going to be equal to 52. So my answer in this problem is going to be 52 x beads and 28 y beads, which total up to 80. And if I wanted to check my answer, I would multiply my 52 beads by 40 cents and my 28 beads by 65 cents and see if that equals $39. And it does. So that's the end of that, and we will now take a more difficult problem that uses the same approach. I'm talking about coffee and trying to maybe thin it out a little bit, because right now Baker Street Coffee House sells a specialty that's $2.15 an ounce. Okay, now the specialty, let's call that my y here. You could call it your x if you'd like, but I'm going to call it my y because I'm going to add some almonds, which are x, and they're quite cheaper. They're 95 cents an ounce. So if I add a $2.15 tea with a 95-cent ounce additive, I'm going to get a blend that's cheaper. So I still have a total, and I still have a dollar amount, but this problem gets a little bit more tricky. Because in this case, my total column is going to be x plus y, and it might be tough to discern what this number is going to be. Well, first let's circle all the numbers in our problem here. And all of these are important. And in terms of total, I'm trying to make a blend of X, which is my almonds, and Y, which is my special expensive tea. So I'm going to make 300 ounces of that blend. Now, in terms of the dollar amount, since my X is my almonds cost 95 cents an ounce. And my tea costs $2.15 an ounce as well. Now, what's the common mistake here is people put down $1.85 as my total, but unfortunately that $1.85 is the cost per ounce. It's not actually the total amount of money that's being spent. See, what we need to do here is multiply by our 300. In the previous problem, we actually knew the total amount of money spent. But in this case, if we're making 300 ounces, we got to multiply that by $1.85 to see how much money that is technically going to make. And so I've done the math on a separate piece of paper, and I know that that is actually $555. So if I make 300 ounces at $1.85, I'm making a total of $555 worth of this special tea and almond additive drink. So now that I have my two equations, my x plus y equals 300, and my 95 cents x plus $2.15 y is equal to $515, what I'm going to do is I'm going to use elimination to get rid of one of these. So let's eliminate the x's like we did in the previous problem. So I'm going to multiply this top line by a negative 0.95 cents. The reason why I like multiplying by a negative is I like to add my problem at the end instead of subtract. But again, if you multiply this whole line by 95 cents, you can then subtract the two. I just prefer seeing the opposites and then have them simplify. Now 300 times the negative 0.95, I did the math on a separate piece of paper, and that's 285 as a total. Now down below, I've got my 9.95x plus my 2.15y is equal to 555. Now what I'm going to do is I'm going to add these up and simplify. $2.15 y plus the 95 cents y, or 0.95y, gives me $1.20 y is equal to, I put these two together, 270. Divide both sides by 1.2 to get my y by itself to figure out how much tea I'm going to need for my how many ounces out of the 300 tea I'm going to need here, and I figured out that answer is 225. So in fact, this is still mostly a tea blend. It's just that it's not all tea anymore because we're going to make 300 ounces, 225 in tea, and I can mentally figure out that x is going to be 75 because 75 and 225 equal 300. So therefore my x plus y equals 300. So I have 75 ounces of almonds. I'm adding to 225 ounces of tea to make 300 ounces or $555 worth of coffee house blend, which is a lot cheaper than using just straight tea. So that's why this mixture equation was brought out for us. Our last problem here in section 3.3 actually doesn't even involve x and y, but it involves a distance equals rate times time problem. When you have a problem that has speed and time and distance, pretty much I can guarantee you're going to be making one of these 3x3 grids, and generally speaking we put these on the test for you so to kind of trigger that oh, it's one of those problems. So distance equals rate times time looks at, in this case, a 740 set jet that flies 4 hours west with a 60 mile per hour tailwind. What this means is that if the plane is going west and there's a tailwind, that means the wind is blowing at the plane's tail, which is going to speed the plane up in terms of its rate. So that rate is going to be some variable x plus 60, and it took 4 hours to travel some distance d. Then it says returning against the east, against the wind, same distance, so it's the same letter d. It's going to take 5 hours, and the reason why it takes 5 hours is x is going to be subtracting 60 because going back against the wind, going against you, it will slow you down. So what we do in this equation, and we have actually two equations in one, we actually have two variables here. So you might think like, well, where's the y? And technically this d is the y. This is the second variable. So we have two equations and two unknowns. So what we're going to do is rewrite the equations. D is equal to x plus 60 times 4, because this is r times t. And this is d is equal to x plus 60 times 5. We'll do some distribution to show you that this is going to be d equals 4x plus 240, and this is d equals 5x plus 300. Now, what makes this equation kind of special here is that unlike the elimination method that I've been showing before and constantly harping on, this is going to be the substitution method. Since I have a variable all by itself, I'm going to take this and plug it in for the one above it. So now I have 5x plus 300 is equal to 4x plus 240. There, I put the 4 in there. Subtract the 4x from both sides and solve for x. You'll notice that there is no other letter here, which is kind of nice. So this is going to be x plus 300 is equal to 240. Subtract the 300 from both sides. Let me think here. Oh, wait a second here. Oh, this should be a minus. So this should be a minus. Sorry about that. A little fix right there. So let's back up a little bit here. This is x plus 60 times 4. This is x minus 60 times 5. So when I do my distribution, this becomes 5x minus 300. So this being a minus in the first place, this then gets added. So 300. So my x is now equal to 540. So again, as a rewind here, I accidentally had my negative, had this a positive instead of a negative. So this is 5x minus 300, 4x plus 240. Then what we have is subtracting the 4x from both sides, adding the 300 to both sides. So the speed of my plane, my rate, because it says how fast is the plane flying without any wind, x is 540 miles an hour. Now, so that means if I'm going with the wind, going west, I'm traveling 600 miles an hour. And if I'm going against the east, I'm traveling 480 miles an hour. And if I really wanted to, I could also find out the distance, like how far was I actually going, by plugging my, like just one of these two equations. Let's plug it into the top one. If I wanted to find my distance, I would just, which isn't asked in the problem. I know it's not asked, but it's just interesting to find out how long the trip was. So take my 540 plus 60, which makes 600. 600 times 4, and 600 times 4 is 2,400 miles. So that's how long the trip was, and the speed was 540 miles per hour. All right, now for the second half of this video is going to be much shorter, but I need you to have your book open because the problems are actually out of the sample section. And I want you to only set these problems up, but do not solve them. And the reason why I do not want you to solve them is because we've actually got a lot of practice in section 3.4 doing these. And double jeopardy is definitely attached because if you get the setup wrong, there's no way you're going to get the problem right. So I'm going to have a spot on the test where there will be a setup only, and then you will have to perform the setup and then just leave it there. So let's look at a setup here and show you how we get it rolling here. Okay, it says set up these equations and do not solve. Page 189, example 1. It's just word problems dealing with writing out equations. It says the sum of three numbers is 4. Now, the sum of three numbers are going to be the numbers x, y, z, and the word is means equals. So the first sentence says the sum of three numbers is 4. So there are the three numbers, and there's 4. Then it says the first number minus twice the second number minus the third number is 1. So there's my second of 3 equations, and one more equation, and I'm all done setting this up here. The last equation says twice the first number minus the second minus twice the third is -1. Find the numbers. And again, the book actually goes through and does this work for you, but again, all I'm really interested in this section is for you to set this up. And we will have other problems in this section where you will fully complete a problem like this by hand because I want to see if you can do all the work accurately. Okay, so in problem number 2, example 2 that's in your book, on page 190, and again, having the book in front of you would really help so you can read this where I'm reading this. Here's what the problem's asking. It says, in example 2, a triangular cross-section of a roof, the largest angle is 70 degrees greater than the smallest angle. Okay, so, well, we got to understand that there are, in a triangle, we have 3 different angles, right? We've got an angle X, an angle Y, and an angle Z. And the largest angle is probably at the top of the roof, and this is just basic roofing because it's going to hold the biggest span right there. So we're going to call our largest angle Z, and our smallest angle, just for alphabetical sake, this is going to be X. So smallest angle is X, largest angle is Z. That means we have an angle in the middle. Since we're assuming that this is not going to be an isosceles triangle or equilateral triangle. In fact, if you look on page 190, you see they've actually done this out and a little bit more to scale than I have, where X, Y, and Z are a little bit more proportional. Now, the book says the triangle cross-section of the roof, the largest angle, so we start off with Z, equals 70 degrees greater than the smallest angle. So it's either X plus 70 or 70 plus X, because it's 70 more than that. Now that's the first sentence. Here's the second sentence. It says the largest angle, so here's another equation with Z, is twice as large as the remaining angle. So that would be 2y, which is the remaining one, is the one we haven't talked about yet. And so you're probably thinking, like, okay, great, I've got 2 equations but 3 unknowns. How am I going to solve this problem? Well, the answer to the problem is pretty straightforward because, is not very, I'm sorry, I misspoke there. The answer to this third equation, this mystery equation that I haven't written down yet, is pretty sneaky because you kind of need to know that all triangles in geometry add up to 180 degrees. Without this equation, you wouldn't be able to solve this because you had 2 equations, 3 unknowns. So there's the answer to problem number, or at least the setup of example 2 in problem 190. And again, you could solve this problem by doing some substitution. And the book runs through this with you. I honestly wouldn't ask you to do this out on the test, though you could easily do that compared to the one I will be asking you on the test. All right, the final example is very straightforward, but there's a lot to keep track of because we're looking at if somebody pays by the gigabyte to download a couple things. This is Kaya. This is on the bottom of page 190 here. Kaya frequently downloaded music, TV shows, and movies. Now, you see that the book lays out the 3 things she's going to download. So, music, it's probably nice to have this kind of written out here. Music, TV shows, and movies. So we're talking, like maybe iTunes and streaming through Hulu and maybe streaming through Netflix or maybe downloading from iTunes or stuff. And maybe this is all iTunes downloading anyway. So here's what we're looking at. In January, she downloaded 5 songs. Let's call songs X. 10 TV shows. Let's call that Y. And then 3 movies, for a total of $55. Must be doing this on their smartphone to get charged by the gigabyte here. In February, and again, I'm creating this equation as I'm reading it here, so it's a pretty straightforward thing since we don't have to solve for this. It says here, in February she spent $195. Oh, look at that, trying to change the order here. $195 on 25 songs, 25 TV shows, and 12 movies. All right. And then in March, of course, this is where the problem's going to end because we have 3 equations, 3 unknowns. Spent $81 trying to trick us by putting that at the start of the sentence with 15 songs, 8 TV shows. Uh-oh, I left the cat out of the bag there. And 5 movies. And you can see that to finish this problem, I would just need operators between these things. And like I did for the March results, you just need a plus. And the plus will take care of, these problems here. And so using the elimination techniques listed on page 191, you can see how they would solve it. But again, for the test, I just want you to set this up. Well, thank you for watching, and I hope the work that you do in sections 3.3 and 3.5 go a little more smoothly because of these video examples here. And again, if you have any questions, please send me an email. Thanks.